So I was sort of curious because I'm like, I've been reading all these research papers, and you look at all these, and you're like, where would you get? I mean, like, it seems like it must be impossible. Like, how would you get like a cut of the whole internet? No, it's pretty easy. This company, this group, Common Crawl, it's an open source group. They they comb through the whole internet. They've built a crawler. It systematically gathers it. You can get it on a monthly basis. They store it on AWS, and it's free. So if you want to go and literally download the internet, yeah, we're going to need a lot of storage, but you can just go download it. So this group, Common Crawl, manages all that. You can go to their website, and they'll be like, basically, this is where you go if you want to download it, and this is what you need to download it. And they've packaged it in certain ways to make it a little more efficient. But you can think, again, for a big company that has sufficient hardware, um, to basically have a little script that just downloads the Common Crawl, it's just not that big of a deal. On the right is the pile. And the pile is a cut that came from the open source community. It was this group, Eleuther. Eleuther used the pile, which was basically a cut of the Common Crawl. They basically did some curation of it. They wanted to put sort of higher quality data. And their premise was, at some point, more isn't better. 800 gigabytes is still a lot. They put it into 22 different categories. So some are like academic and technical, some are more news, but they really tried to build a standard data set and made the whole thing open source. So again, you can see for free, download the pile. You can get all of it. Then I just cut a little image below this book corpus. A lot of people use the book corpus, which, there have been a lot of commentary. It's not a very high quality source. It was a bunch of free novels. There were copyright issues. There was repetition issues. There were definitely questionable content, like whether the content was suitable. But a lot of the models use the book corpus for simple reason. It generates lots of beautiful text. So when you have page after page of a novel, it gives really fluid, beautiful, rich text. So a lot of the models have been trained on the book corpus. And again, it's a relatively small data set. I mean, we could actually download this and run the book corpus locally. But likewise, it's free and easy to access. All right, I've mentioned these instruct data sets a bunch of times. So I want to spend a couple minutes because it's so smart. It's so simple, but it's so smart. And I hope it's clear. These are 3 separate samples. These are packaged in what's called JSON-L format. All that means is each line, that's the L, JSON-L, each line is a separate entry, a separate training sample. And the only reason I'm mentioning JSON-L is that's actually what OpenAI uses, and that's become kind of the standard. So all these models expect data sets now packaged as JSON-L, which is just this. It's actually very simple. It's fairly intuitive to read. Each thing that's inside those little curly brackets, that's a JSON dictionary, and that is one training sample. So on this page are 3 training samples. And the really clever idea is, all right, what you really want to do is think about this like a conversation. So what you really want is you have, in this case, a human saying, what are some tips for creating a successful business plan? That's what the human would say. Or that's what the human might enter into a ChatGPT. What are some tips for creating a successful business plan? Then you package in the same text the response from the bot. And then you can see this would be what you would hope the bot would say in response to that feedback from the human. Now, what this actually creates when you do enough of these is it basically creates, using the training of predict the next token, a perfect way to do it. When you go in to use the model, you're the human, you enter in the human part. What's going on behind the scenes in the model, they take what your input is, what are some tips for creating a successful business plan? They prepend to your prompt the human. And then what's the next token? Well, the next token then is bot, which they postpend your thing with. And then they let the model do its thing. And the model has, in effect, been trained in this way of, yeah, I got that input from the human. All right, it says bot now. What is the most likely token for the bot to start to say in response to this prompt? And so by giving lots and lots of samples like this, it goes beyond that storytelling of once upon a time, please complete the story, to now the input that you're giving, what you're asking a chat GPT is something really complex. It has all sorts of instructions in it. You're saying, summarize this, explain that, give me an answer to this. And the model, by having millions of examples like this, has been trained on this is how I'm supposed to respond when a user asks these kinds of instructions. So these were 3 prompts, real ones, from that open source Instruct data set. They gathered 40 million samples of this that are all in open source now. So just like all this stuff is out there, this is the base of the cake. This is the icing on the cake. It's all out in open source now. So there are going to be a lot of OpenAI clones because a lot of the raw ingredients now are out in the public domain. Now, here are just a few examples. And I mean, I don't know. I mean, maybe a lot of areas of like science and innovation work this way, but what's just truly just shocking to me, like when I read all these papers, is they put it all out there. It's all in the public domain. And again, it doesn't mean that there isn't some secret sauce that they hold back or they don't disclose, or of course, increasingly OpenAI and Google and Microsoft are going to do that. They're going to hold back more and more of what they're doing to give themselves some competitive advantage. But all of these are from published research papers. You could spend a couple minutes, you could Google it, you could download the paper, and it gives all the specifications. So in the middle, you see the GPT-3 paper, kind of a watershed paper that was written in July 2020. It was published by OpenAI. It's probably the most quoted, cited paper other than the attention is all you need paper. 175 billion parameters. They trained it on 300 billion words. It's a decoder-only transformer. They laid out all the parameters of how to put together the architecture, the hyperparameters that they used in the training. They trained it for the equivalent of hundreds of days on special GPU hardware that Microsoft created and made available for them. And then again, one of the things that it's become a standard that they do is they disclose what were the sources of training data that they used. 60% of GPT-3 was that common crawl data. 22% was web text. 16% was the books 1 and 2 corpus. 3% was Wikipedia. Wikipedia also, I can show you the link. Same thing, you just go to a Wikipedia download dump page, you can download all of Wikipedia. So that was GPT-3 3 years ago. On the left, that is one of Google's state-of-the-art models. This was a paper that they published about a year ago. It's the model I think they're probably going to publish first. 137 billion parameters. You can see they trained it with 5 times as many words as GPT-3. Maybe they were hoping that would be like their edge. You know, if we train for 5 times as many, maybe we'll see a better effect. Not 96 layers. They have 64 layers. The dimension of the model is a little smaller. They had slightly different batch sizes. Their training was fairly comparable. And then look at their training data. Now, they were purposefully trying to build something that would be a dialogue and chat kind of capability. So most of this is what's turned into Bard. So they took 50% from dialogues from public forums. You can imagine Google must have a lot of public forums where they had data they could easily go aggregate. But then again, Google, like 12% from that common crawl data, 12% from Wikipedia. When they say programming in QA sites, they really mean like, OpenStack, whatever the thing is that we're on all the time, or Reddit. And then they use some English and some non-English. You flip over to the right, a model that I am really interested in is this GPT Neo X. It's a 20 billion parameter model. It is the largest fully open source model, meaning they've made everything open source. The model, the weights, the training data, every facet of how they trained it, it is fully open source. And this is from that Eleuther group. 20 billion parameters. You can see they actually trained it for the exact same number, as Google. Decoder only. And what they actually trained it on was the pile that they built. And the thing that stood out to me, just looking at this, the reason I wanted to just sort of lay it out is going back to my comment. Core of this stuff might be impossibly complex, but it's actually really easy because in a practical and functional way, the way that these models are described and differentiated from each other are a handful of parameters. And so if you kind of get over maybe the discomfort of, oh my God, I mean, what's all this crazy calculus stuff and the optimization and blah, 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 and all the layers? What it really comes down to when a state-of-the-art researcher is publishing their paper, it's a handful of these parameters, and that's how everybody communicates with each other. And so at some level, like, do you really have to know the inner workings of the attention mechanism and how the self-attention head and this layer? No. Oh yeah, their model's 44 layers and has 20 billion parameters. The Google model has 64 layers and 137 billion parameters. And then the Bloomberg model, and this just came out last week, 50 billion parameters. They used 363 billion words of training. What was really interesting is 26% on the pile, 19% on the common crawl, 3% on Wikipedia. I actually would have thought they would have used a lot more Bloomberg data, but like most of it was actually the same base of the cake. They just added then a little bit of their secret sauce, into the mix. And now, I always think about it like a steak restaurant or something. Like if you get a good piece of meat and you have a really good oven, there's only so many ways. There's only so many different variants, right? So some might say, oh, we like a little spicier. We get a little, crust on the edge or something, And so like GPT-3 and OpenAI, they would say that they deduplicated a lot of the data. So again, they didn't do fine-grained anything, but they ran some scripts to deduplicate where they thought there was a lot of redundant data. They do all their training with slightly fewer words than other people do. So 300 billion words as opposed to like a trillion words, right? The GPT-3, they emphasized bigger batch sizes. They emphasized using the full context window in every training batch. So what they would do, they would just stack up training samples. So they'd have one training sample. If it was less than the context window of 2,000 tokens, they would just stack in as much of the next one as they could. But they would always fill up those 2,000 tokens. Now, these are relatively small things. It's not clear that that's like the magic. The GPT Neo X, they actually said, we tried deduplicating. We didn't see any benefit from deduplicating, right? They said, we think there's benefits to the pile rather than the common crawl because it's been curated, it's higher quality. We're removing, some of the junk out of it, right? A Bloomberg might say, our secret sauce is we're going to have financial data, right? So we're going to get rid of some of those other things that aren't specific to our use case. The Google, they might say, well, we really trained it with a lot of this Q&A and back and forth, so conversationally it would be better. The Neo 4X, one other thing I forgot to mention, they said, well, we're going to build our model with a slight variant in the way that we're going to set up the layers of this model. The other thing that they did, they actually said, we're going to build a new tokenizer based on the statistics of the pile, rather than the same tokenizer which everybody else uses. They all use the same tokenizer otherwise. So there are like these little variants, but again, it's almost like when you go into a really nice steak restaurant, yeah, you know, some they might have like really nice potato that comes on the side. Others, their thing might be the seasoning that they put on the steak. Some might be thicker, some might be narrower, but all these are just like relatively small variants. And to some degree, it's all these parties trying to figure out like, will there be one little thing that's a little bit better or a little bit different? Because so much of the core of the cake is exactly the same. Now, I realize this is kind of hard to read. In fact, well, hopefully you can start to see most of it. I just went to Wikipedia and just said, what's a list of the large language models? And it was even kind of shocking to me how many were here. Most of these I've heard of, but not all of them. And you can see starting on the left with BERT, the GP2, the GPT-3, then the Eleuther group. I mean, it seems like ancient history 2 years ago, a 2.7 billion parameter model. Then they released the 6 billion parameter model. Then, you know, Microsoft and NVIDIA were like, you know, screw all this, and came up with a 500 billion parameter model. And that really set off kind of this arms race, that and GPT-3. And even a couple of years ago, there was a lot of speculation of, hey, I mean, at some point, is bigger really better? I mean, is it really going to make that big of a difference? But the results that they saw was yeah, that once these models got to be tens of billions of parameters, their ability to kind of learn nuances of language was notably better. And that set off this whole arms race. And then you can see all these other models. Bloom was this whole thing Hugging Face did that I don't think has really, you know, taken off. There are a couple of models in China. You can see the Baidu model, 260 billion parameters. I think there's another model in China that also is like hundreds of millions or even maybe low trillions of parameters. Google did some model, 1.2 trillion parameters. I suspect that, you know, whether it's Google or others, they've tried basically to go as big as you could possibly go, and have probably realized at some point diminishing returns. So I would guess that the number of parameters probably doesn't get that much bigger for a while, unless they start to see that it's really yielding, you know, huge benefits from where things are today. You can see then on the right, Claude, you know, that's the model from Anthropic, 50 billion parameters. They've just launched their API, which I think is actually really good. The DeepMind, a 280 billion parameter, you know, model. Lambda is that model that I showed the research paper of. Chinchilla is kind of a famous model from DeepMind, but I don't know if anybody knows exactly what's in it. But it's kind of famous, this Chinchilla model. The Google Palm model, which I don't think is the one that they're releasing, it's 500 billion parameter model. OPT, Google's gone Facebook has gone a totally different way. They're open sourcing everything. So the OPT models are 100% open source and completely available for anybody who wants them. And then you can see this GPT Neo X, again by Eleuther, growing from 2.7 billion parameters, 6 billion. Now their kind of state-of-the-art model is a 20 billion parameter model. And again, you kind of see in some ways these are commodities. Like it's the model, you know, the size, the number of parameters, the corpus that it was trained on, maybe a couple of other bells and whistles, but there's a lot of them already out there.